A fairy coin is flipped 8 times. What's the probability that it lands heads up exactly 4 times? Express your answer as a common fraction. Well, first question is, what is a fairy coin? And a fairy coin is a coin that has equal chance to land as head and as a tail. So it means that probability of head equals to probability of tail and equals 1/2. So for this kind of coins, the probability we are looking for, we can calculate it by the following formula. So it's a ratio. On the top we have a numerator, number of outcomes that have exactly 4 heads. And on the bottom we have a total number of outcomes if I flip a coin 8 times. Okay? So what do I mean by number of outcomes? Well, I'm throwing coin 8 times. So for example, I can have something like this. 8 times I can have head. That's an outcome. One of them. The other possibility, well, I have first tail and then 7 heads. That's another outcome. Or I can have head, then tail, then heads again. That's the third outcome. I can have more complicated things. For example, head, tail, head, tail, head, tail, head, tail. It's another outcome. Or I can have something like 4 heads and 4 tails. And there are many, many more outcomes you can come up with. But essentially, one way of doing this is just write down all possible outcomes and count them all. And that's going to give us n total. Now, that's the first part. The second part, just go through this list and find the outcomes that have exactly 4 heads, like the ones in red here. Okay? And if we go through the list of all outcomes, we find the ones like this, we count them all. That's going to give us the number on the enumerator. Right? But obviously that would take forever if you try to do something like this. We need to do something smarter. But essentially what we're going to do is we're going to calculate this number and this number. Okay? And then divide one by another. We start with the total number of outcomes. Alright. So how many outcomes do I have if I throw a coin 8 times? Well, let's start with one throw. How many outcomes do I have if I throw a coin once? Well, 2. Head or tail. Right? What if I have 2? I throw a coin twice. What's going to happen? Well, the first throw is head or tail. There are 2 options. And for each of those options of the first throw, I have 2 options for the second throw. Right? I can have head or tail. So if I throw a head first, the second one could be head or tail, and I get head, head, and head, tail. Or if I got tail first, the second time, again, I can get head or tail. So the total number of options is actually 2 options in the first throw, and for each of those 2 options, I have 2 options for the second throw. So 2 times 2 is 4. Right? Now, what if I have a third throw? Now, what's happening? I can get head or tail. And those are 2 outcomes for each of those 4 outcomes I had before on the first 2 throws. So this is what it's going to look like. And the total number of outcomes is actually doubles. Okay? So if I had 1 throw, I had 2 outcomes. If I had 2 throws, I had 2 to the power of 2 outcomes. If I have 3 throws, I have 2 to the power of 3 outcomes. If I have 4 throws, 2 to the 4th, obviously. And if I have 8 throws, I have 2 to the 8th. 8 power outcomes. And that's 256. So we figure out how many total number of outcomes I have. Now I need to figure out how many of those outcomes are outcomes with 4 heads. Now, the way we're going to look at this is we're going to consider those 8 throws as 8 positions, right? This is the first throw, second throw, third throw, and so on. Okay? And then somewhere in those 8 positions, there are heads, 4 heads. So we're placing 4 heads into 4 spots out of 8. Okay? How many ways can I do this? So to make this problem maybe more familiar, let's replace these H's with balls. Problem like this, I have 4 balls, 4 black balls, and how many ways I can put 4 black balls into 8 positions? Right? Notice all balls are different, all balls are the same, they're indistinguishable. Now, you may know the answer to this question already, but if you don't, let's continue. So, before we're going to talk about indistinguishable balls, let's consider the balls of a different color. We have 4 balls, and let's say they all have different color. Now the question is, how many ways I can put 4 balls into 8 spots? And the balls are distinguishable now. Okay, so let's put the balls out. And let's say, well, I'll pick up the first ball, it's red one. How many ways can I put red ball into 8 slots? Well, there are 8 ways. There are 8 slots. There are 8 places, right? All right. So let's put the ball somewhere. Okay. Let's say it got here. Now the question is, once I put the red ball here, how many ways can I put the green ball after I put the red ball? Well, there are 7 spots left. So obviously there are 7 ways to put the green ball. But remember, that is 7 ways to put green ball for every position of the red ball. And there are 8 positions of red ball possible. So total number of combinations we can have for red and green ball are 8 times 7, or 56. There are 56 ways to put 2 balls into 8 spots. And this is one of possibilities. Now, once I put 2 balls in, well, the next one is purple ball. How many ways can I put a purple ball here? Well, there are 6 slots left. So there are 6 ways to put this ball for each position of these 2 balls. Right? And there are 56 of those. For each of these 56 positions of these balls, there are 6 ways to put the purple ball. So the total number of positions, 8 times 7 times 6. And obviously, now, in a similar manner, how many ways can I put the black ball? There are 5 places, so we multiply it by 5. Okay, and that's going to give us total number of ways to put 4 distinct balls into 8 spots. Okay, so, but remember, our problem is not distinct balls. Our problem is indistinguishable balls. They're all the same. So for this kind of problem we just looked at, when the balls are different, what you see here are 3 different positions. They counted as 3 in this number, okay, because their colors are different. Although they sit in the same positions, in position 2, 3, 6, and 8, but they have a different color. Okay? So, but this is not what we want to look at. Our situation is like this. They're all the same. So for us, these 3 positions I have is actually 1 position. And what we did, we actually counted the same position multiple times. Right? So to really find the answer to our problem, we need to figure out how many times we counted this position or any other position. Okay? So let's go back to our distinguished balls, distinguishable balls. And now we want to figure out how many ways I can put these 4 balls into these exact four spots. How many ways can I shuffle these balls among these 4 positions? Okay. Alright. I have 4 balls. And first, I want to put a ball in this position. That's the first position for me. How many ways can I put a ball here? Well, there are 4 balls, so there are 4 ways to put a ball here. Let's put some ball there. It's one of the ways out of 4. Now, the next thing we want to fill is this position. How many ways we can put a ball there? Well, there are 3 balls left. So what does it mean? It's 3 balls, so there are 3 ways to put the ball in this position. But remember, it's 3 ways to put the ball here for each of the 4 ways to put the ball here, which means total number of ball positions is 4 times 3. Well, we have 1 ball here. The next thing we do is we put a ball here. Well, there are 2 ways to put. There are 2 balls left. For each of the 12 ways, we can fill the position 1 and 2. I mean, this is the first positions. Alright? And obviously, the last one is filled automatically. It doesn't have a choice. But really, there are 4 times 3 times 2 times 1 ways to shuffle 4 balls in 4 spots. Okay? So what does it mean? It means that when we calculated this number, okay, for each position, if we just replace this colored ball with black balls, for each of this black ball position, we counted that position that many times in this number. Okay? So really, to find the actual number of different positions we have with the black balls, we need to take this number and divide by number of shuffles, or number of permutations we had for 4 balls in 4 positions. Okay? And that's going to give us the number of 70. So total number of ways we can put 4 balls, 4 balls of 4 heads into 8 positions is 70. And the probability in this case 70 divided by 256, or 35 divided by 128.